Okay, so we're going to look at multiplying polynomials today. So not just binomials by binomials. What if we have a trinomial times a trinomial? Okay, so when multiplying each term in the binomial, so when we multiply a binomial times a trinomial, multiply each term in the binomial by each term in the trinomial. It's basically the same thing as you did with the binomial. Zach, do you need to sit in the front? Thank you. Everyone in block 2 and 3 is going to hear this. Okay, so it's really going to be extension from Friday. So like terms are monomials with same variables and those variables have the same exponents. So monomials with some variables, with same variables, and those variables have the same exponents. So for example, 2x squared y and 5x squared y. They both have x's. The x's are both squared. They both have y's, and the y's are both power of 1. Those are like terms. Okay, or I have this example down below. So why are these all like terms in this example? The 1/3 xy squared, negative 2xy squared, and 6xy squared, yeah? They all have xy squared. Okay, so we're not going to use, does anyone want to take a guess why we're not going to use algebra tiles when we're multiplying these trinomials? Yeah, it's also because we don't have a three-dimensional type board. Could we put an x squared tile on one of the dimensions? Does that make sense to have an x squared tile on one of the dimensions? Well, if you're multiplying an x squared by an x, you're going to need an x cubed tile. Well, that doesn't, yeah, it would be 3 dimensions. So it doesn't make sense, other than binomials, right, to use algebra tile. So here we're going to just use distributive law, or you can use the chart. Do some of you really like that chart? You like the distributive law? Yeah, that's good. You want to be comfortable with distributive law because if you're going into dash 1 especially, that's what you're going to use, right? You're not going to use charts. So here, let's multiply 5x plus 2 by this trinomial. So how would you think we'd set this up? 5x times the bracket, x squared plus 2x plus 1. And then, so first the 5x times that full bracket, and then plus 2. Make sure you have your sign. The plus 2 times, so we're going to multiply the 5x by that whole trinomial, and then the 2. So really, is it much different than last day? No. The only difference is we're going to have more like terms. Okay, so let's expand this. 5x times x, 5x cubed, plus 5x times 2x, 10x squared, 5x times 1, Carson, 5x times 1, 5x, yeah, 2 times x squared, 2x squared, 2 times 2x, 4x, and 2 times 2, 2. Okay, so notice how we have more like terms now. What like terms do we have here? The x squareds. I like that little method you're using, Yep. I'm going to do that. And then the x's. Yeah, those are the like terms. So let's combine those. So we still have, what would we write first? Yeah, we write highest degree to lowest. So first the 5x cubed plus 12x squared plus 9x plus 2. Okay, really quickly, I'm just going to show it maybe for this one example. Could you use a chart in here? You sure could. Right, we have 5x plus 2. It doesn't matter where you put the 5x plus 2, right? Nope. Let's put it on the top. And then we have an x squared plus 2x and a plus 1. So really quickly, it's really the same idea. 5x cubed, oops, cubed, 2x squared, 10x squared. Now what's really cool about this, 4x, 5x, and 2, is where are your like terms going to be? Diagonal. So these two and these two are like terms. Okay, the diagonals. The nice thing about the chart, it really kind of organizes those like terms. Does it give us the same final answer? A 12x squared, yeah. 9x's plus 2 and a 5x cubed. Okay, so let's look at the next page. Are you ready to try that next one on your own, or do you want to do one more together? Are you ready? You're ready. Okay, so why don't you try A on your own? Let's give it a shot. So if you're confused, just look at the previous example we just did. If you're finished early, compare with somebody else, see that you got the same answer. I'm going to show you a little shortcut today on how you could check your answers with your calculator. What? Some very high powers here. Are you overwhelmed when you're in the presence of higher power? Higher powers? No. No? Okay. Sometimes these brilliant jokes just come to me. Okay. So your first step should look like that. Okay, your x squared, you're going to multiply by the 2x cubed plus x minus 5, and then you have minus 4 times the 2x cubed. Remember that sign has to be there in front of that number. Okay, then you're distributing in. So first we have x squared times 2x cubed. You should add 2x power of what? 5. Yeah, we add our powers when we're multiplying. X squared times x. 1x cubed, right? It's just a 1 times 1. You don't have to write a 1. X squared times negative 5. Negative 5x squared. Yeah, we just write them beside each other if they're not. One's a coefficient, one's a variable. Negative 4 times 2x cubed. Negative 8x cubed. Negative 4 times x. Negative 4x. And a negative 4 times a negative 5. Plus 20. Where do you think students make silly mistakes? Positives and negatives are signs. Yeah, that's always where silly mistakes are made. Okay, like terms. Where do we have like terms? What question? Great, the x cubes and the x squared. Nope. Nope, no x squared. Just the x cubed. So, what's the coefficient for x cubed if you don't see it? 1. So, what's 1 minus 8? Negative 7x cubed. And then we still have the minus 5x squared we have to write out, the minus 4x, and the plus 20. What would you call that polynomial? Just a polynomial, right? After 3 terms, we don't have a special name. We just say it's a polynomial. Okay. How would you set up b? Yeah? Okay, so what would it look like first? What's the first thing I'd write? Times the set y minus 6, and then times y minus 6, and then negative 7 times y minus 6. So the trinomial's first. That's okay. We'll multiply each term in the trinomial by each term in the binomial. Could we have done it another way? Yeah, Maddie? Right. So multiplication is the same as Maddie was saying, is when you 3 times 4, it's the same thing as 4 times 3. So if you want to write less, you could have also wrote y times 2y squared minus 3y minus 7, and then minus 6 times 2y squared minus 3y minus 7. Doesn't matter which one you do. No, which one did you write down? Did you write down this bottom one? Yeah, I'm gonna go with that one. You can write down either one. Okay. So it's just be careful of signs again. But you're gonna get the Okay, so either way, if you expanded that method or this method, you'll notice you'll get the same expansion. So 2y squared times y, 2y cubed, minus 12y squared, and negative 3y times y, plus 3y squared. So the only difference here is the order of your terms, depending on the method you use. Okay, negative 3y times negative 6 plus 18y, negative 7 times y, negative 7y, negative 7 times negative 6 plus 32. And then what do? Like terms, so we have y squareds and y's. So if you did it the other method, you'd have the same like terms. It might be a little bit different order in the middle, but you'd have the same numbers. And you get the same final answer. Negative 12 plus 3, what does that give us? That's a cube. Negative 9y squared, good. 18 minus 7 plus 11y plus 42. So if you did it the other method, did you get the same answer? Yeah? Oh, yes, thank you. Yes, so this right here should have been what I multiplied. Negative 3y times y should be negative. So, Miss Johnson, Miss Tisk, minus 15y squared. You were all looking at me funny, and I'm like, what's going on? That's what's going on. Okay, if you did it the other method, did you get the same thing? Yeah. So the other method might have been not only less writing, but safer. Okay, let's look at something totally different that you haven't seen before. Yes, so when we have a cube, it means we're going to multiply it by itself 3 times. Now, this is different. Okay, you haven't seen a binomial times a binomial times a binomial yet. It's a tongue twister. Okay, let's talk about multiplication. When you multiply, how many things can you multiply at a time? Do you have 2 times 3 times 4 memorized? No. So when we multiply, we always go how many things at a time? 2 at a time. So say 2 times 3 is 6 times 4 is 24. Or you could also go, what's another way we can multiply this? The 4 times the 3, so 2 times 12 is 24. we can only multiply two things at a time. Okay? So that means we're only going to multiply two things at a time here. So should we start with the first two? Okay. So we're going to multiply these two together. The other guy we're going to leave on the outside. Okay? Now, the only difference here is we need brackets. We're going to need brackets around what we get for this multiplication when we expand that. We need brackets for the 2x minus y, the other guy that we're leaving out. Okay, so we only can multiply. We're gonna figure out what this equals first. So how would we multiply him? What would it look like inside here? 2x times 2x minus y, and then the minus y times the 2x minus y. So there's kind of a lot of brackets here. We might want to use square brackets. I'm not sure. So inside this bracket, what does it look like now when we expand that? 2x times 2x. 4x squared. Oops, I'll use blue. 4x squared. And now, 2x times negative y. Negative 2xy. Now, negative y times 2x. Negative 2xy. Remember, we always write it alphabetically. So x first, then y. And then negative y times a negative y plus y squared. Okay, so what can we do first before we take care of the next multiplication? Yeah, make life easier on ourselves by combining like terms. We have 4x squared. What's negative 2 minus 2? Nope. Negative 2 take away another 2, right? And then plus y squared. Okay, do we know how to multiply a trinomial times a binomial? Yes, so now we're back to where we begin. Let's make this less writing. So how could I write this with less writing? Let's use Maddie's method. 2x times 4x squared. So instead we're going backwards. We're going to make 2x times all of this. And then we're going to multiply the negative y by that bracket. Okay, so finish this question off. Collect like terms, and then compare your answer to the answer I get on the board. Okay. Running out of room, or are you okay? I'm good. You're good? A little bit? This is interesting. Have you guys yet experienced multiplying a 2x times a negative 4xy? What would that become? So negative 8, then what would happen if you multiply x times xy? X squared, so the x is times x is x squared, and then we have the y. So x times xy is x squared y. Right? The same basis, we add the powers. Plus 2xy squared, and then minus, negative y times 4x squared is minus 4x squared y. We go, the x's first, then the y's. What would it look like when I multiply negative y times negative 4xy? Positive 4xy squared. Yeah, there's two y's now. And then negative y times positive y squared. Negative y cubed. Really ugly, I would say. Spotting your like terms, you have to look very carefully. The x squared y and then the xy squared are like terms. So 8x cubed. Negative 8 minus 4. Negative 12. Is that what you guys got? negative 12x squared y. And then plus 2 plus 4 would be a plus 6xy squared minus y cubed. Tough question. No? It's okay? Yeah, it just, and you know, questions like this is where we make silly mistakes, especially the long ones, right? Okay, so we are almost done. Turn to the next page. Could we skip D? Let's do E. We will do F, but we're going to do E and F, okay? And then I'm going to show you after, in F, how to check your answer with your calculator. Okay, so again, how many things are being multiplied together here? 3. And how many things can we multiply at 2? So where do you want to start? The first two, 2 times 2x times w. Will you still need brackets? The answer is yes, because we're still having to multiply by this guy. Okay? So because there's 3 multiplications, when we bring in this 2, we're still going to put it in brackets, because this product is being multiplied by 4x plus 7w. Okay? So what does that give us for this first guy? 4x minus 2w, 7w. Good. And now is it easy? Yeah. So first 4x times 4x plus 7w. And then the minus 2w times the 4x plus 7w. Okay, finish that one off. Is everything okay? So get the 4x times all of that, and then the minus 2 times all of that. Oops. Okay, are you writing it wx or xw? If it's alphabetical, it doesn't have to be. XW is fine, as long as you keep them all the same order. But if we do alphabetical, wx, 28wx, minus 8wx, plus, nope, minus, 14w squared, and what does our final answer look like? What do we have to collect? 16x squared plus 20xw or wx minus 14w squared. No, it's fine. As long as it's highest degree to lowest, they all have the same degree, so it wouldn't actually matter. Often in math, x takes, I don't know, x is like the ruler of all. We always use x. I don't know. It's a good question. Common used mathematical letter.
I watched the video once about why they use X as some other and not some other level letter, but I forget what it's called now. It was a TED Talk video.
Was it?
Yes.
Oh. Okay.
And it's also why X rays don't X-ray because they what kind of they didn't know it was like ultraviolet or
So they called it X for X-ray? Huh. That's good to know. Anthony's full of knowledge. Fun facts, yeah. Something's wrong with this picture. Something has to be changed. What's wrong? It's squared. How do we rewrite a square? You write it twice. Would this be on the test? Yeah, it could be. Oops. So, another thing that might cause us some difficulty here? There's a lot to do. Okay, yeah, Bria? Yeah, the -3. Here we were multiplying three things together, right? So let's take care of the -3 first. So how many things at a time can we multiply? 2. So let's multiply -3 by the bracket he's beside. Well, we still need brackets. Yes. Okay, so -3 times x. -3x, what's -3 times -1? Plus 3, and then we have x minus 1. Now, this guy here, do you want to expand him right now, or do you want to do him later? Expand him now. Okay, so what would that look like now that I want to expand that guy? How would you write that if you want to expand him? X times 4x plus 5, then, yeah, and if you want, if that kind of is confusing to look at, you could even, if you wanted, put square brackets around that, right? That's that expansion. You don't have to have them, but if that makes more sense to you, you can do that. Okay? So now can we expand this guy? Yeah, right? The brackets make it more confusing? Okay, take them out. See, you just throw them away. Alright, so he's going to look like -3x times x minus 1. He's going to look like plus 3 times x minus 1. Right? We okay with going from there to there? No questions? Life is good? Okay. Now, could we go ahead and expand this now? Sure, why not? So plus x times 4x. 4x squared, x times 5. Plus 5x, -1 times 4x. -4x, -1 times 5, -5. It's long, okay? It's pretty long. Hey, so now going on to our next step. What can we do now? Going from left to right. We could also combine like terms, and we'll do that when we get down there. So we're going to collect like terms. What else are we going to do? Expand these guys. Yay! Do you want to try and finish this on your own? Sure? Just keep, yeah, we're going to add them once this, now we have both multiplications done, add the like terms. So once you're done that expansion, you just go ahead and add all the like terms. We're done all the multiplication, and so now we can take care of addition. It's amazing how something so ugly can look so pretty at the end. So simple. Right? Did everyone get the same thing? Did I add? Oh, yeah. 5 minus 4 is 1x. So then when we have 5x, 3 plus 3 plus or minus 1. No, it's a plus 1. Gives you a 7. Miss Johnson. Tell I'm not all here today. Okay. Did you get the same? How about the ones? Who did? What did you get for a final answer?
I got x squared plus 11x minus 8.
Okay, so take a look here. Let's go through this. So negative 3x times x is negative 3x squared plus 3x plus 3x minus 3. Okay, these two are going to become a 6, right? And then this adds to just 1. And when we multiplied here, we had a 4x squared, 5x minus 4x minus 5. Okay, so the negative 3 and the negative 5 make a minus 8. The x squared, it's negative 3 plus 4 is a 1. And 3 plus 3 plus 1 gives us a 7. Okay? And I'm going to show you how to check your answer. So how do you check your answer? Well, you need to learn how to store something in your calculator. So grab your calculators. No. Okay, let me show you. So make sure you're on the main screen. What you're going to do is you're going to choose a number for x. Because right now, if your calculator was reset, x wouldn't be stored as anything. Mine might be because I've used it as, I stored it as a number before. But if you push x, enter, does yours actually give you a number? No, right? So we're going to learn how to store a number as x. Okay? So it doesn't matter the number, pick any number. 2, 5, doesn't matter. So type in a number. I'm going to use 5. Okay, it doesn't matter. Don't use 0. You could use 1. I would use 2 or higher. Okay, so now you're going to push the store button. So you first push and take a number. And the store button is STO right above the on symbol. So where I'm pointing. Where the arrow is pointing. Okay, and then you're going to choose x. Choose your variable. So x is right there. It's the xt alpha n right below the mode button. 2 down, 2 right. And then, so 5 store STO. So I'll write this down on the board here. So you pick a number. Then you're going to push the store button. Then xt alpha n button. And then enter. Okay, that xt alpha n just means it's a variable. So this one. You could use an alpha, but if you use alpha, then every time you have to push the alpha button, right? We can just use the X button. It's always a lot easier. It's just one button right here. Then push enter. Okay? So now if you push X and push enter, does it give you that number?
Yes.
Yes. So now what we're going to do is we're going to type in the original. Okay? And it's going to actually calculate it with X equal to 5. So X minus 1 squared plus, bracket has to look exactly how it looks in the question. Same brackets, 4x plus 5. Okay, so we're typing in, and it's going to actually plug it in with whatever number it's solving for x equals 1 and outputs you a number. So for me, it's 52 because I stored x as 5. Your number might be different if you stored x as something else. Okay, then what do you think we're going to type in? Our simplified answer. Is this really the same thing as that, just more simplified? Yeah. So x squared plus 7x minus 8. See, it's nice using x because I don't have to push alpha every time. That's an extra button for every time. 52. So we did our simplification right. Okay, so let me see who typed it. Make sure you're using the minus sign, not the negative. Okay, so make sure when you're using your minus sign, not your negatives when you have subtraction. Okay, so those should be only a negative when it's in front by itself. That gives you the 52. Okay, good? So again, You're using the negative sign instead of the minus inside these brackets. So if you can go through, can you change that? Or, yeah. So this would be a minus sign. Minus sign. You can just go backwards. Or how did I get the actual thing?
Yeah, how did you get it? Like this?
Whoops. One more time. Well, I don't know. I just pushed enter when it's all black. And it'll let me edit it. Okay, so let's see. 4x plus 5. There you go. Okay? So you have to make sure to, like, these guy right here would be a minus sign, minus sign, minus sign. And then only the guy in front. So this is a minus sign, right? Only the guy in front would be a negative sign. And then you'll get the right thing. Okay, is that kind of cool? Way to check your answer? Could you store it as other letters? Yeah. You could just use a number. Then you would have to actually sub in carefully. 5 minus 1 squared plus bracket 5 minus 1 times 4 times 5 plus 5. Yeah, so you could also use a number instead of actually storing x. And then 5 squared plus 7 times 5 minus 8. 52. You could just store it as a new number. So you can go 4 store x. Now it's 4. Enter. It doesn't affect it. It won't affect it. It doesn't make a difference if it's stored as a number. Yeah? Can you also store y? Yes. So if you want to store, say, y, guys, so if you have a question with x and y, pick a number for y. So say 6, store. And the only difference is you have to use the alpha button. So alpha and y is number 1. So every time you want to type in y, you'd have to go alpha 1. Okay? 2 times y would be 12. That's very nice. Okay. Are we ready to move on? Cool. How are we doing? We're doing okay. This is a really good question. I might come back to this. How much time do we have? And I still need to do our lesson. We might come back to this another day. Okay? So let's look at the very last question. I will tell you this. This is going to be your unit exam written response question. And it might even show up on your final, something like this. Okay? Yeah, so this is super important to be able to solve a problem like this. So in this problem, guess what we're trying to find? The area of the shaded. So area of the shaded. Usually the dimensions are given a little nicer. So I'll give you arrows. So this is this portion here. That's that portion here, here, and here. Okay, tell me how we can get the area of the shaded. What are the different strategies we could use? Anthony, what's one?
Well, what I would think is you would have to, oh, I see, this is just for this length. Because if it was for the whole thing, then I would think you would multiply the whole thing and then subtract this.
Yeah. So you said if we had the full dimension, could we easily get the full dimension? Could we just add those together to get the? We could. And then we could find the area of the whole minus the area of the white box. That would work. Do you want to use that method? Okay, you could also cut the box. I don't know. We could also cut it. So you could do area 1 plus area 2. Okay, you would still have to do some addition either way because I'd need this dimension, which we'd have to add those together. So either way, we're still going to be adding sides together. So which method would you like to use? The first one? The large minus the small? Okay, so we need to figure out this full length here. So how are we going to get that? 6x plus 8 plus x plus 2 is what? 7x plus 10. Where you have to be careful is on a test I might give you this full dimension, 7x plus 10. I might give you this small one, but I don't give you this. So what would you have to use in that case to get this subtraction? So you have to be very careful with subtraction, right? But I gave it to you. Okay, how about this side? How do we get that? Same way, we're going to add these two together. So collecting like terms is how we add. 3x squared, 8x plus 4. Good. Okay, so our area of our large shape, we're going to do the area of the large first, and then we'll find the area of the white box, and then we're going to subtract them. Okay, so how do we do the area of the large? Length times width. So multiply them. Who do you want to write first? The 7x plus 10 or the large 3x squared plus 8x plus 4? Sure, 7x plus 10 times 3x squared plus 8x plus 4. Okay, can you go ahead and multiply those? So first the 7x, and then the 10. So when you're done, take a look at the board. So that's the area you should have got for the large. Okay. Okay, that's fine. Okay. Now we need to do the white area. The white area. So what are the dimensions of the white area? X plus 2 and 2x plus 1. Oh, 3x plus 1, thank you. So go ahead and multiply those. When you're done, see if you get the same thing. So you should get 3x squared plus 7x plus 2. Or am I going too fast? Good? Okay. So our last step is our subtraction. So we want to take the full area. We're almost done. And then we're going to subtract away the, I might move this up here. So our large area minus our shaded. Now, do we have to have the brackets here for the shaded? Yes. Why? Why? What operation is telling us we have to have brackets? Subtraction. Okay. Now you could subtract, or what could we do to make it distribute the negative, make it addition. So to make this a plus, this would be a negative 3x, a negative 7, and a negative 2. If you use like a red pen, it's easier to see, like a different color. And now we can collect like terms. So there's no other cubes, so 21x cubed. So now we have 86 plus negative 3 is 83x squared. And we have 108x plus negative 7 would be 101. And then plus 40 minus 2 plus 38. Plus 38. Yay, a lot of work, hey? Okay, so that's going to, for homework for tomorrow, that's going to be part of the homework for tomorrow for the first assignment. Okay? So, before we get started,